Welcome. We'd like to introduce the topic of why is KNX the best technology for energy transition in smart homes and buildings. We have with us the CTO of the KNX Association, Joost Demarest, and he's going to be talking about as the market and the world moves towards renewable energy sources, some competing technologies bombard home and building owners with some different solutions to move from fossil fuels. But whenever you add applications, you add complexity. And complexity in the home or the building is best designed, configured, managed, and maintained by competent professionals. That means KNX is the better solution with building blocks proven through the years. This presentation will show why the approach often suggested by competing technologies is usually not the right choice.
Good day, ladies and gentlemen. My name is Joost Demarest. I'm the KNX CTO and CFO, and I will tell you why we continue to think that KNX is a valid technology option for energy management. Here, a brief outlook on what I will tell you. So first we will look at what houses were like in the past, and unfortunately also a lot of houses are still like that in the current days. So we will look at how can or could houses be like when we have concluded the electrification process. Do we or will we manage to make this transition between former houses and the houses we intend to have after the electrification process? What is needed to get the job done? We will also look at the current market situation and the current facts there and the promises that are offered in the market. And from an experience, what could be the better approach, already indicating that the facts and the promises that we are given in the market are not the most ideal approach in our eyes. And I will conclude with an outlook on the international standardization as regards energy management. Let's have a look at the houses we used to live in and to a large extent we are still living in. If we look at this marvelous couple over 50, they seem to be very happy in their old house. Maybe it's not as run down as this picture gives the impression, but in there is some quite old stuff, like this boiler with gas produces heat during the winter and also foresees in hot water during the entire year. Possibly this old couple has this kind of car, of course still using fossil fuels, and possibly they still love to cook on a gas stove, and possibly they are using still this kind of phone, a cordless phone. But if we look at this young couple, for instance, is more like looking at this kind of house. So a modern style house and a modern style house calls for modern equipment like this heat pump or this hot water production via solar energy. And of course, the home wants to be, or the energy supply is also mostly covered by the solar panels on the roof, using this converter to convert the electricity for use in the home. And of course, since all is electric, this couple also has an electric car. It can charge at best with the solar energy it produces. And if there's any surplus energy, the couple also has a battery to store the surplus energy. And of course, needless to say, the couple has quite a number of white goods in the home, a dishwasher, a washing machine, a fridge, and an electric oven. The couple, of course, is also, because of recent activities throughout Europe, they are connected to the grid by means of a smart meter. The couple also has smart lighting bulbs in the home. The rooms can be individually regulated as regards heat production or cooling production. The couple or the home has electrified blinds. Of course, a young couple without a smartphone is not a young couple. They've got audio, video and audio control in their home, and they have smart speakers. Of course, a modern home needs to be well protected, so they've got also an alarm central, and they have other things like fire protection, smoke protection, etc. So if we look at that modern home, the electrification will add considerable more elements to an already complex surroundings of a home. And if all these different islands work as islands and independently from each other, then this will be very counterproductive. Just listing a couple of examples here. As I already said, if we are producing in this modern home surplus energy, then we want to store it in the battery. And this energy we want to use when production is low and or when energy prices are high. We want to do the washing, or we want to charge the car, at best with own produced energy, so not energy we draw from the grid. We heat or we cool the home when we need it and where we need it. So we don't heat up the bathroom in the middle of the day. Of course, this smart home needs to be linked to the internet. For instance, we could install a weather station, but at best we simply link to a service that is offered in the internet for weather forecast, so that the house would lower the sun blinds on a hot day to lower the energy needed to cool down the home. Or the other way around, we move the blinds up on a sunny winter day to lower the energy needed to heat the home. And of course, we would like the devices to be ready. For instance, the e-car, we want it to be loaded by a certain time X when we want to leave with the car and leave to go to work. We want to avoid peak consumption by having too many devices active at one point in time. So we don't want to charge the e-car at the same time as when we start the dishwasher. When we have this smart alarm, we want a connection between the alarm and the other applications in the home. So when we leave the home, we activate the alarm. We want the house to be put in standby mode. So also there to lower the energy consumption. And all this data, I want permanently as a homeowner to be able to look at this data. And where do I look? Of course, on my phone. And I want to be able to operate my entire home also via this fancy control panel that I have in my pocket, being my smartphone, even when I'm not at home. And for instance, if I have an Alexa in my home, I want to use voice control to operate all these things in my home. So there is an absolute need to link all these applications to a single home network. communication should be possible via wired or wireless possibilities. And very important, this whole home network needs to be secured. We don't want a hacker to infiltrate our home via the internet, because our home is connected to the internet. And we also don't want a hacker to be standing in front of our door or being 30 meters away from our home and eavesdropping, because the hacker is able to record the wireless communication. We also don't want, or actually the energy suppliers don't want this, they don't want us to be able to tamper with the data that are consumption data. So the smart meter should give a true reflection of what we actually produce or what we consume in our home. The network needs to be as standardized as possible so that any equipment from any manufacturer should be able to hook up to this network. And also the communication protocols that are used on these networks should be standardized, because we don't want multiple gateways in our home to be able to talk between application A and application B, C, D, etc. And also for the manufacturers should be able to buy chips that are off-the-shelf chips. So we don't want any exotic chips as manufacturers. We want simply chips that are omnipresent to be able to use this in these different applications that I have just mentioned in the previous slide. So ensuring a very quick time to market for the products of the different manufacturers. And of course, the data that is being produced by these different applications needs to be well aligned. We don't want a temperature being sent by one manufacturer in a 4-byte format and the other manufacturer uses a 2-byte format. This is not what we want, because this might lead even to chaos or possible unwanted effects between products of different manufacturers. So let's have a look at the current market. What does the current market offer the current customer? The current market situation is that the consumer is confronted with a multitude of different network infrastructure solutions. And the customer is confronted with mostly manufacturer-specific communication protocols. Even if these manufacturers use standard technologies, they will still make something that is manufacturer-specific and cannot be linked to a product of another manufacturer. And the market gives the impression that every single consumer will be able to manage his or her own network, his or herself, and configure everything with the help of an app on the personal mobile phone. If you remember the slide from the slide I showed you 3 slides ago, the complexity of a home is quite substantial. So not every homeowner may be able to manage his or her network, his or herself. Or there's even manufacturers claiming that, okay, all our products will be plug and play. So you plug them in and all of a sudden they work together with this vast network of other applications. Let's not forget that every manufacturer on the market has an own commercial interest, which is of course fine. And if functionality of, for instance, a certain product type is standardized today, for instance, a heat pump, then manufacturers may wish to add additional features to the standardized solution to distinguish themselves from the other manufacturers. And if we standardize something today, this does not mean that this is still the perfect solution in 10 years from now, or even in 2 years from now, because of the very rapid pace by means of which technologies evolve these days. And not to forget, we must make sure, even as a manufacturer, if I release a product today, I must make sure that the updated product in 2 years from now is still able to be included in an installed installation from 2 years ago, because otherwise I even create incompatibilities between my own products. So let's look at how KNX has done it in the past 3 decades. It has been a technology for home and building automation that has been in the market for more than 30 years. It is standardized as an EN, a Chinese and worldwide standard. It ensures backward compatibility, so every new product can be installed, can be added to the installed base. It allows wired and wireless communication. True, this is a KNX specific solution, but it also offers IPv4 and IPv6 communication. So thanks to KNX IoT, we can now also integrate into a KNX installation, even an existing KNX installation. We can integrate products that are based on Ethernet, Wi-Fi, Thread, all of that with state-of-the-art security. For IPv6 communication, there is even an open source stack available. And very important, the manufacturers can use off-the-shelf components. And most important, small installations can be managed by a homeowner, but bigger installations, even a very modern house, as I have demonstrated, with multiple applications, is better managed by a professional. KNX has a network of more than 100,000 KNX installers worldwide, the so-called KNX partners. So if you are completely unsure about managing all these applications, you can simply get yourself the help of a KNX partner. And all of this linking of all of these different products is done by an application and vendor independent configuration tool, ETS. And most important, we do standardize functional blocks in KNX, but we give the manufacturer the freedom to add functionality if this functionality is encoded with KNX standardized data types, because we have an installer that is able to manage this extra functionality. There's a human being that actually links all these products together, and we do not rely entirely on plug and play and manufacturer specific apps. And also very important, devices are certified. So we check the compatibility of products. We don't do that ourselves. We rely on third-party certification when we brand the products with the KNX logo. And since KNX IoT, there is even a RESTful third-party API to link third-party devices to a KNX installation. So there is even an EN standard already in place that documents this third-party API possibility. So to round off my presentation, let's have a look at international standardization. So also in international standardization, a lot of technical committees look at the topic of energy management and try to standardize this application domain. KNX has cooperated with Senelec TC205. So that Senelec TC205 deals with home and building electronic systems. And this technical committee has established the EN 50491-12-X series. The standard describes how the energy needs or the energy offer of any product type can be abstracted towards a central customer energy manager. So an installation will consist of a customer energy manager and a number of different resource managers that are the abstraction of the energy need or the energy production of any product type. There are 5 control types that are standardized for different types of devices, for instance, for white goods, for batteries, for e-cars, etc. KNX can be used to transport these different control types, but any communication protocol out there could be used to transport this data. At least this EN5491-12-X standardizes for all these different protocols the application data for energy management use. So this already greatly improves the communication between different solutions. The standard is already a standard in Europe, but the standard is being converted as we speak into an international IEC standard via the technical committee IEC SC23K Working Group 3. Ladies and gentlemen, thank you very much for your attention on my presentation on energy management and KNX.